Hi everyone, welcome to your online lab. In this lab, we're going to focus on the learning outcomes that we look through in the week 5 content, which is the skeletal system, or at least cartilage and the skeletal system. So I've got the learning outcomes here up on the screen, and the types of learning outcomes we're going to focus on today. Well, firstly, the learning outcomes for this topic include briefly explain the function of each of the 3 types of cartilage. So that's the first point. The next is describe the basic structure and function of bone and how different cells contribute to physiology. Outline the process of calcium homeostasis. List and locate the major bones in the skeleton and understand the basics of synovial joints. What we're going to focus on in this lab is what the students will be focusing on in their actual physical lab, and that's going to be predominantly looking at a couple of things. First, learning outcome, which is briefly explain the function of the 3 types of cartilage. That's going to be the first learning outcome for today, and the second will be list and locate the major bones in the skeleton. The reason why is because the others we've done a number of videos for that really go through the details. Because it's more, so the function of bone physiology, that's a physiology video, not something I can really highlight when we're going through cadaveric specimens or going through the anatomy app that we're going through today. So we won't be going through that. The process of calcium homeostasis as well, won't be going through that. And understand the basics of synovial joints. That's something that I've covered extensively in a video. So these are the 2 learning outcomes that we're going to focus on today. So let's first start with briefly explaining the function of each of the 3 types of cartilage. So what we've got here is the skeleton, and the skeleton has a number of joints. These joints are articulating surfaces. That means one surface comes in contact with another surface. And you can see that there's going to be cartilage associated with it. Often, cartilage is going to be found at these articulating surfaces, and cartilage is present to reduce friction. That's one of the reasons why it's there. One of the main reasons, in actual fact, why it's there. So the presence of cartilage is to reduce friction. That's the first thing, when 2 surfaces are rubbing, but it's also as a shock absorber. And it's also, so if we're going to highlight all the functions, reduce friction, shock absorption, but also as a malleable bit of connective tissue. And I'll talk about what we're meaning there. So malleable obviously means we can move it around. It's bendable, it's flexible. Bones aren't really that flexible, but cartilage can be flexible. So in areas where we need structure and support, we may also need it to be slightly flexible. And an example of that is the nose, for example. So there's no bones there in the nose, but there is a lot of cartilage because we need structure, but it also needs to be flexible. Same with the ear. Now let's just have a look and let's just focus on the 3 different types of cartilage. So let's label or name these 3 different types of cartilage. We've got hyaline cartilage. We've got elastic cartilage. And we've got fibrocartilage. Let's have a look at where we can find these different types of cartilage. So areas of examples. So first of all, let's look at the hyaline cartilage. This is the most abundant type of cartilage. Hyaline cartilage is found at all articulating surfaces where one bone meets another bone, particularly that of long bone. So remember, a long bone means the bone is just longer than it is wider. It's not an irregular bone, it's not a short or flat bone, it is a long bone. And so examples of long bones include, if we have a look, at the shoulder joint, this surface here is going to be hyaline cartilage. So this is the humerus, for example. You can see at the shoulder joint, this is hyaline cartilage articulating in with the scapula, which is that bone there. At this surface of the long bone, that's the humerus, it's articulating with the ulna and the radius. So they have articulating surfaces as well. It's all hyaline cartilage. So that also means that if we look at the femur of the leg, that it's going to have hyaline cartilage at one surface, hyaline cartilage at another surface. So just think about all the long bones. That also means the bones at the fingers as well. They're going to have hyaline cartilage at their surfaces too. So that's all hyaline cartilage. Now hyaline cartilage is also found at the ribs. So you can see when we look at the ribs that we've got our various ribs here that connect from the vertebrae to the sternum. But we also have some ribs here that have cartilage associated with it. And so this cartilage is also hyaline cartilage. It's called costal cartilage, so cartilage of the ribs, but the type of cartilage is hyaline cartilage. So you can see that hyaline cartilage is found at all articulating surfaces of long bones and of the ribs. And finally, you can see hyaline cartilage at the thyroid here and also at the nose. All of this is hyaline cartilage. Now let's have a look at the next type of cartilage, which is elastic cartilage. Now, elastic cartilage by its name is elastic, it's bendy, it can move. There's not too many examples of hyaline cartilage, but one of which is the ear. The ear is the major type of hyaline cartilage that we can see. Next type of cartilage I want to talk about is going to be that of fibrocartilage. Fibrocartilage is there to resist compressive forces, and therefore any area where we've got weight stacked on top of each other is where you're going to find fibrocartilage. And so a great example is that of the intervertebral discs. We have one vertebrae and another vertebrae stacked on top of each other, and the intervertebral disc is going to be made up of fibrocartilage, and it's densely wrapped connective tissue, cartilage, so that when the compressive force occurs, it distributes that weight. You also find fibrocartilage at knee joints as well, for example. So while you are going to have at the articulating surface of the knee hyaline cartilage, you also have a little bit of fibrocartilage in between. These are the different types of cartilage and where you can find them. So that's the first learning outcome done. Okay, so a couple of things we're going to look at now is basically that list of bones that you need to know for your exam. So there's this list. You can find this list on the Learning at Griffith page. Once you go into topic 5, which is bones and joints, you'll see that in the course content area, there is a little Word document that you can click, and it's got this list. So we're going to go through these bones and bone groups one by one, talk about where they are, where you can locate them, and a little bit about their function as well. So what we're going to do is we're going to start off with the skull and facial bones. So we're going to first begin by doing these ones here. So these are going to be the skull and facial bones. We're going to highlight where they are, what they're called, and some of the functions as well. So what we've got here is the skull, and we're going to go through these bones one by one. So the first bone we need to look at is that called the frontal bone. So we're going to start off by looking at the very top of the skull, right? So this bone right here, that's called the frontal bone. Interestingly, underneath it, we're going to have the brain, right? That's going to be the frontal lobe of the brain. We haven't done nervous system yet, but when we do, you'll go, oh, it's exactly where it sits. Then we're going to have the parietal bone. So that's the left. And the right parietal bone. Again, sitting underneath that are the parietal lobes of the brain. We look at the back, we have the occipital lobe. Again, the occipital lobe of the brain sits underneath this. And then finally, the temporal lobe. Sitting underneath that, or the temporal bone, underneath that is the temporal lobe of the brain. Now some other important bones of the skull, that's called the sphenoid bone, which we can see here. And then we've got the top of the jaw called the maxilla. So you've got the left maxilla and the right maxilla. So the very top of the jaw here, what we call the immovable part of the jaw. Then we've got the movable part of the jaw here, which we call the mandible. And the mandible obviously can open and close due to certain muscles. Interestingly, if I were to isolate it, you can see that these bony projections here called epicondyles, they're going to articulate in with the skull itself. So you'll find that if I was to hide this, it articulates in here with that of the temporal bone. All right, so that's called the mandible. Now some other aspects, let's bring that mandible back. Some other bones that you need to be aware of include, if I were to actually take that jaw away, because we need to look under and within, So that's going to be the maxilla that we spoke about before, the immovable part of the upper jaw. But this is called the palatine bone, the palatine bone. And the palatine bone, you can see, articulates in with the back of the maxilla and that of the sphenoid bone as well. Another bone that we need to look at is going to be that of the nasal bone up here, but also the zygomatic bone. The zygomatic bone, actually, you can see has connections with the frontal, the sphenoid, and the temporal bone. Now you can see that there's these suture-like, they're actually called sutures, but these suture-like structures that separates each of these bones, and they're not straight. They're like this because it increases the surface area for them to contact one another, so it's a stronger joint. It is a joint, it's just an immovable joint. Synovial joints are movable joints, these are immovable joints. And again, they're called sutures. So the suture here that separates out the frontal bone from the parietal bones, that's going to be called the coronal suture. And then the suture that separates out each parietal bone is called the sagittal suture. So that's really important. So let's just reiterate what we've gone through. The bones of the skull include the frontal, the parietal, the occipital, the temporal, the sphenoid, then we've got the zygomatic, the maxilla, the mandibular or mandible, and the palatine. These are bones of the skull that you need to know and be aware of. Now we're going to have a look a little bit lower, and we're going to have a look at the hyoid. Now the hyoid, interestingly, if I flip this around, is a bone that looks like it's floating. And in actual fact, it is a floating bone. That's the hyoid there. It's only held together by muscles and connective tissue. So it's one bone that's actually not touching any other bone. Now above it, it's attached to the tongue. Below it, it's attached to our larynx. So it's really important when it comes to moving the tongue, moving the larynx, articulating while we speak. So it's a very important bone for speech, articulation, and swallowing. And that's the hyoid bone. Now what we're going to do, we're not going to have a look at the fetal skull because we don't have an example of the fetal skull here, but we're going to move on to the vertebral column. So as you can see here, I've highlighted the vertebral column for us, and it's highlighted in green, and you can see the vertebral column begins at the base of the skull and finishes right down at our hip in what looks like a little tail here, and we'll go through all that. Now importantly, the vertebral column transmits weight, it's weight bearing, and obviously as we move down the vertebral column it's holding more weight, and that's important because when you look at the bones of the vertebral column, it begins, if I can draw, it begins up here by looking quite small, but as we go down they get larger because they need to hold more weight. So the body of the vertebrae needs to be bigger. Now, I think that it's important for us to have a look at the vertebral column by itself, and there's multiple vertebrae. So the first thing I want to talk about is we're going to start at the very top, and we're going to look at the very first two vertebrae, part of what we call the cervical vertebrae. If we were to actually have a look, when we look at the vertebrae, there's 7 cervical vertebrae. So 1, 2, 3, 4, 5, 6. 7 cervical vertebrae. The next lot of vertebrae are called the thoracic, and you can very easily tell when we're hitting the thoracic vertebrae because they look different. See how when we look from here to here, there's none of these little things sticking out the side. We know that that's the thoracic vertebrae as soon as we see these called the spinous processes, because what these things do, that's where the ribs articulate, and the ribs only articulate with the thoracic vertebrae. So that's super important for people to be aware of. So you can tell the difference between a cervical and a thoracic vertebrae because of these spinous processes. The other thing is when you look at the spinous processes of the cervical vertebrae, there's holes in them, right? There's one hole here, hole, 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 hole. What are these holes for? It's for a blood supply that goes up to the brain, right? So you've got the carotid arteries and you've got these various cervical holes or foramina that allow for another blood supply to get up through. Now, we've spoken about the 7 cervical vertebrae. There's 12 thoracic. So let's see if we can count those 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you can see the spinous processes change. And we've got 5, 1, 2, 3, 4, 5, what we call lumbar vertebrae. 1, 2, 3, 4, 5 lumbar vertebrae, and then we hit the fused sacral vertebrae. So this whole thing here, that's the sacrum, and it's 5 fused. 1, 2, 3, 4, 5, and then we hit the tail, also known as the coccygeal, and it's 3 to 5. 1, 2, 3. This one's got 4. All right, 3 to 5. So that's the vertebrae, and you can see anatomically they're quite different from one another. So if we start with the first two, like I said we were going to do, the very first one is called the atlas. Cervical vertebrae 1, also known as C1. It's called the atlas. If you have a look at Greek, it's either Greek or Roman mythology, where there's the guy that's holding the world above his shoulders. His name is Atlas, the god Atlas, because he's holding the world. You've heard of an atlas before, which is a map of the world. So atlas means world. This is called the atlas because it is holding the world above its shoulders. What's the world? The skull. The skull sits immediately above the atlas. That's how you know. Then you've got underneath that the axis. And the axis is important. It's named because axis means turning. It allows for the C1 to turn above it. You can see there's this thing here called the dens, this thing that pops up, and that dens allows for it to pivot. When we go through synovial joints, right, you're going to find that this is a type of synovial joint. Make sure you have a look and figure out what type it is, and that's part of the axis. Then we move through and we've got the rest of the cervical vertebrae. If I were to isolate a cervical vertebrae, if we can, let's isolate C4, for example. What are the things that you can see? So you can see that we have the body of the vertebrae. That's the largest part. That's the weight transmitting part. You've got the spinous process and you've got the transverse process. You can see there's an area here where one cartilage is talking to the next. One bone is talking to the next above it. And this little gap here, that's going to be for the spinal cord. And these gaps here, these foramina, meaning little holes, that's for blood vessels to move up. All right? All right, so that's the cervical vertebrae. When we have a look at the lumbar vertebrae, when we have a look at, the thoracic vertebrae, let's look at thoracic vertebrae 8, if I can. Let's look at thoracic vertebrae 5. What do we see? Again, we see a spinous process, right? That's the thing that you can feel or see when you look at the back. Spinous process, transverse process, and that little hole here, that's for the spinal cord to move through. Now, importantly, it's called the vertebral foramen. I'm just having a look at my notes to see what parts I need to show you. Yep, spoken about the spinous process, transverse process, vertebral foramen, and these are articulating surfaces. So that's called a facet joint, right? That's where the rib attaches in. One rib, another rib, all right? So that's really important. Again, you can see it looks very different to the cervical because it's got the facet joint for the ribs and there's no foramina here. All right, let's go back. Let's now have a look at our lumbar vertebrae. Now, importantly, the first thing you see is look at the size of the body of the lumbar vertebrae. It's transmitting a lot of weight, so it's a lot larger. Transverse processes are smaller, spinous processes are smaller. There's no articulating surface here on the spinous process. There's no area for the rib to articulate in because the lumbar vertebrae has no ribs. And then we move down, and you can see as we move down, we've got the sacrum. And you can see that's going to be part of the hip joint as well. That's the articulating surface there. And another articulating surface. If we go back, you can see what it's exactly articulating with. It's articulating with that of the ilium. So that's the wing of the hip is the ilium. And then we've got the tiny little coccyx or coccygeal down the bottom. So this is our vertebrae. all the bones of the vertebrae as well. Now, last thing we want to look at here before we move on. So all we've looked at so far is what we call the axial skeleton. All right, so I've highlighted that here. All we've looked at is the axial skeleton. That's the skull, the vertebrae, and now what we need to look at is the rest of the axial skeleton, which is the ribs and the sternum. So let's have a look. Let's look at the sternum first of all. This is the bony front portion of our sternum. The end there is called the xiphoid or xiphoid process, and up here it's called the manubrium. So let's do from superior to inferior. Manubrium, sternum, xiphoid process. All right, importantly, let's start with the manubrium. The manubrium of the sternum, you can see, articulates in with the clavicle. Clavicle talks to the manubrium. Clavicle talks to the manubrium. Underneath that, the sternum. What does the sternum talk to? The ribs, but through cartilage. So there should be cartilage here, here, here. All right? And then the xiphoid process doesn't really do much. What's it say? Xiphoid process, inferior portion, articulates with the body of the sternum at the end. So the xiphoid doesn't really do much. It's just a little bony structure that points out at the end. Now let's look at the ribs. So we've got the ribs. How many ribs do we have? Well, let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is probably a better view. Let's isolate. Might be easier. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ribs. Is that a surprise? How many thoracic vertebrae do we have? 12, right? And they're the ones that articulate with the ribs. So at the back, right, what we're going to have is the 12 thoracic vertebrae, unsurprisingly. And at the front, this is where they start to articulate in with the manubrium. And then we've got what we call the floating ribs, right? So the ribs that don't articulate in, if I can put the connective tissue in, let's see if I can do that. There we go. Perfect. All right. So what we can see is how the ribs articulate in with the sternum. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those 12 ribs do that. And the other 2 are called our floating ribs. They don't articulate with anything at the end. But that's important because this is around about the level where our kidneys sit. Right? And that's important because if somebody's in a car accident, these floating ribs can wrap around and slice those kidneys. Very important. All right, we are now done with the axial skeleton. We need to look at the appendicular skeleton. Okay, so what we've done is the axial skeleton, like I just said, and we've done all these areas as well, so we can tick these off, right? We've done all this. We're now looking at the appendicular skeleton. So we're first going to look at the upper girdle, and the upper girdle is going to be this area here, so it's going to be scapula and clavicle, which we sort of looked at briefly, but we'll go back through it. Then we're going to look at the upper limb, which is going to be the humerus, the radius, and the ulna. Then we're going to look at the wrist and the hand, and we're going to go through some of these important points. So then we're going to look at the pelvic girdle, but we'll come back to this particular page in a minute. So here is the appendicular skeleton. As you can see, it's going to be made up of the scapula, the clavicle, the humerus, the radius, the ulna, all the various bones of the wrist, which you do not need to know, and then the metacarpals and the phalanx or phalanges of the hand. Then we've got, when we look at the hip, what we're looking at is the ilium, the pubis, and the ischium, and then we've got the lower limbs, which is going to be the femur, tibia, which is our shin bone, fibula, tibia, fibula, and then again, bones of the ankle, and then bones of the feet, which is going to be tarsals and phalanx as well. All right, so let's go back. What I want to start off with is the scapula and the clavicle. So let's have a look. What we've got is the clavicle here. It's a very weird bone. It's an S-shaped bone, right? As you can see here, it's got that S shape to it. And on one surface, it articulates in with the sternum, and the first rib. And on the other surface, it articulates in with that of the scapula. And you can see that here. So there's the two bony surfaces. Now, importantly, if we move on to the scapula, it's got these various surfaces of the scapula. So let's just isolate that. So when we look at the scapula, whoops, we've got these various surfaces. So we've got these processes. That there is an articulating surface called the glenoid, and the groove is called the glenoid fossa, and that's where the head of the humerus is going to fit in, so the upper arm. Now, what I want to show you is that there's actually going to be muscles attached here, which hopefully I'll be able to bring in and I can show you that. Let's add some muscles. There we go. These muscles are important. These muscles form the rotator cuff. And you've heard of the rotator cuff. If you're moving your arm, you're going to have this muscle supraspinatus, infraspinatus, and teres minor, and then there's going to be another muscle underneath here called subscapularis. 4 muscles that together form a cuff. I'm going to put the connective tissue in so you can see it. Whoops. Form a cuff called the rotator cuff. And that's this cuff that sits, hopefully I can, although I haven't put it in, unfortunately, it's not available here, but there's a rotator cuff that forms this tissue right here and allows for you to internally rotate your arm, externally rotate your arm, abduct your arm, adduct your arm, and so forth. All right, let's get rid of these muscles. We're not looking at muscles this week, we're looking at bones. Then we've got the humerus, and you can see the articulating surface of the humerus head right there. There's the humerus, and it goes down, and the humerus articulates in with both the radius and the ulna. How do you know which one's which? Think about your hand, right? So your thumb can move in a circle. That's called a radius. So the bone that's closest to your thumb is going to be that of the radius. So that there is the radius. That's how you remember that. And then the other one is called the ulna, and the ulna has to do with your funny bone. So when you hit, that is your elbow. The ulna is elbow, and you can see that there. So that is your elbow, okay? Then when we move down to the hand and the wrist, we've got the various bones of the wrist, which you don't need to know, but you do need to know those of the hands. So we've got the metacarpals. We've got 1, which is the thumb, 2, index, 3, middle, 4, ring, and 5, pinky. And then we've got the phalanx. So we've got proximal, intermediate, and distal, right? So you've done proximal and distal before. Closest to the site of attachment, furthest. And they're the phalanx, right? So proximal, medial or intermediate, and distal. And again, you can do that with the first phalanx, second phalanx, third phalanx, and so forth. That's the hand. Next, we're going to go down to the hip, pelvic girdle. So we've got the ilium. So the 3 parts of the pelvic girdle are ilium, pubis, and ischium. And they're all attached to each other, right? Pubis, ilium, which is the wing, right? Ilium is that wing of the hip. Pubis, which you can think about, it's the front, forms the pubic bone, the front, the bony projection at the front that you can feel. That's the pubis. And then the ischium underneath here. What you'll find is that if I were to hide the femur, you can see that the acetabulum, which is the joint, that's where the femur articulates into, that's going to be part of both the ilium, ischium, and pubis, not both, all 3, right? You can see they're all there. So all 3 of those bones come together and cumulatively form that joint where the hip goes into. So here's the lower limb, right? This is the femur. This is the biggest bone in the body, the longest bone in the body. You've got the head of the femur that articulates in at the surface, at the acetabulum, and then you've got the distal portion of the femur. And what you'll find, if I get rid of the patella, known as the kneecap, right, and have a look and see how let's remove this, you can see that the femur so unlike the humerus, which articulates with both surfaces of the radius and ulna, the femur articulates only with the tibia, the shin bone. And you can see that there. So the other bone that's sitting here, the fibula, the smaller bone, only articulates in with the tibia. It doesn't touch the femur. And it moves down to form our ankle as well. And then when we go and have a look at the foot itself, similar to the hand, you can have all these bones that make up the ankle's equivalent of the wrist, but then you're also going to have the tarsals. So carpals in the hand, tarsals in the feet. Carpal, tarsal, right? Think of tarsal toes. Carpal, think of the hand. So you're going to have metatarsal, 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 metatarsal. So just like with the hand, the thumb was number one, the big toe is number one for the foot. And then you're going to have the phalanx, 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 and so forth. And there we go. That's the appendicular skeleton. So now what we've gone through are all the bones, their location, some of their functions of the bones list.